Hello everyone. In this video, you will study about the calculation of median and mode for individual, discrete and continuous data series. Before moving in this video, take a look over the learning contents. Learning contents of this video are calculation of median for individual series, calculation of median for discrete series, calculation of median for continuous series and graphical location of the median. Calculation of mode for individual series, calculation of mode for discrete series, calculation of mode for continuous series and graphical location of mode. You will also study about the empirical relation between mean, median and mode. I am Narendra Sharma and I will elaborate all these contents one by one in this video. Calculation of median. What is median? Median is a positional average. It is the middle number of the ordered data series and it divides the ordered series into two equal parts. Number of observations smaller than the median is equal to the number of observations greater than it. So here you see the data series. It is in ascending order. The data series is 2, 4, 6, 8, 10, 12 and 14 and 8 is the middle number of this data series and this is the median of this data series and it divides the data series into two equal parts. 2, 4, 6 less than 8, 10, 12, 14 are greater than 8. So this is the median value of the data series. Now how would you calculate the median for an individual series? For an individual series, the median can be calculated in two ways. If the data series is odd number series, then the median will be size of n plus 2. This item will be the median of the for the odd number series. And for an even number series, the average of the two middle numbers of that ordered series is the median value. M denoted for the median, N is denoted for the total number of items in the series. Now this example showcase how would you calculate the median for an odd number data series. So this series is an odd number series. Total number of items in this series are 9 and here the data series arranged in ascending order. N is 9, M is the 9 plus 1 divided by 2. This item is the median. The size of this item is the median value. So 9 plus 1 divided by 2 is 5. So the fifth item is the median value and the fifth item is the 18. Therefore 18 is the median value of this data series. Now this example showcase the how would you calculate the median for even number series. This series is even number series and the total number of observations are 8. Therefore n is equal to 8. Now the average of the two middle numbers, the two middle numbers are 4th and 5th number and the average of these two numbers can be calculated by 282 plus 296 divided by 2 and this will equal to 289. So 289 is the median value. So this way you can calculate the median value for in even number individual data series. Now how would you calculate the median for discrete data series? The formula for calculation calculation of median for discrete data series is same as the individual data series, odd number data series. So M is the size of n plus 1 divided by 2. This item is the median value. But how would you calculate the median for a discrete data series? The steps for calculation are given here. First you need to arrange the data series in ascending or descending order. Then you need to find the cumulative frequency. Then you need to find the value of median using the formula size of n plus 1 by 2, this item. You need to locate the n plus 1 by 2, this item in the cumulative frequency. Then corresponding value of the variable against the located cumulative frequency is the median value. So you can better understand this by this example. So here the data series given in this first row, and the corresponding frequency of the data values are given along with the each data value. So 10, 12, 14, 16, 18, 20 and 22. So the data series is in ascending order, and the corresponding frequencies are given in the second row. You need to first arrange in the column wise. So in the first column the data values are given here, and in the second column the corresponding frequency are given in here, and now you need to calculate the cumulative frequency value in third column. How would you calculate the cumulative frequency? Take the first value as it is, then the 2 plus 5 7, 7 plus 12 19, 19 plus 20 39, 39 plus 10 is 49, 49 plus 7 56, and 56 plus 3 is 59. The sum of the frequencies is 59, and the last cumulative frequency is also 59. Now the median will be the size of the n plus 2 item. Size of the n plus 2 item is given by 59 plus 1 divided by 2, n is 59. So n plus 1 is 60, and 60 divided by 2 is 30. So the 30th item will be the median value. Size of the 30th item will be the median value. Where is the 30th item? 30th item lying in this cumulative frequency, in the 39th cumulative frequency. Here lies the median. So the median value lying against this cumulative frequency is 16. So 16 is the median value for this data series. So this way you can calculate the median for discrete data series. Now how would you calculate the median for continuous data series? The formula for calculation of the median for a continuous data series is here. M is L1 plus n by 2 minus CF divided by F into I. So what are these? L1 is the lower limit of the median class. CF is the cumulative frequency of the class preceding the median class. The class which comes before the median class is the preceding class. So CF should be taken of the preceding class of the median class. F is the frequency of the median class, and I is the size of the class interval, that is width of the class interval. So you can better understand by example. So here is an example to calculate the median for a continuous data series. Here the percentage profit of sales is given in this first row. 0 to 10% earned by 22 companies, 10 to 20% earned by 38 companies, and 20 to 30% earned by 46 companies, 30 to 40% earned by 35 companies, and 40 to 50% earned by 20 companies. So you need to arrange the data by column wise. So in the first column the profit share shown in this here, and the frequency, that is the number of companies, corresponding companies according to the profit. 0 to 10 earned by 22, then 38, then 46, 35, 20, and the total number of companies are 161. So the sum of the frequencies is 161. N is, or you can say that the n is equal to 161. Now you need to calculate the CF, cumulative frequency, 22 as it is, then 60, 106, 141, 161. Now the median is size of the n plus 1 by 2th item. So size of the 161 plus 1 divided by 2 is size of the 81st item. Where is 81st item? 81st item lying in this cumulative frequency, 106. So where is the median class? The median class is 20 to 30 is the median class. So the frequency of this median class is 46. Therefore L1, what is L1? L1 is the lower limit of the median class, which is what is the lower limit? 20 is the lower limit of this median class. N is 161. N is 161. Then cumulative frequency is taken for the cumulative frequency is the preceding class of the median class. So 60 is the cumulative frequency because 10 to 20 is the preceding class to the median class. Now F is 46. 46 the median class frequency of the median class. Then I, what is I? I is the class width. Class width is 10. Now put all these values in the formula. M is equal to 20 plus 161 divided by 2 minus 60 divided by 46 multiplied by 10. So this will equal to 20 plus 4.46 and the median will come as 24.46. This is the median value for this data series. This way you can calculate the median for a continuous data series. Now how would you locate the median on the graph? So the graphical location of median, first you need to convert the given distribution into less than or more than cumulative frequency distribution. Whatever the given distribution, you first arrange the data according to the frequencies should be arranged either in less than way or more than way. Then draw a less than or more than ogive curve or the cumulative frequency curve. Then compute n by 2 and locate its median item on y-axis. Now draw a horizontal line from this point on y-axis so as to meet at ogive curve or the cumulative frequency curve. Draw a perpendicular line from the point of intersection on x-axis. Then the point of intersection on x-axis gives the value of median. So you can better understand by the example. So here is the example. I have taken the same example as in the continuous data series. The example for the continuous data series. So first you need to arrange the data values less than way. So I have you can arrange the data values in less than way. Here the values are arranged in the data values are arranged in a less than way. So how many companies are 0 to 10? Class 22. And how many companies would be in less than 20 profit share when the profit share is less than 20 is 20 plus 38 is 60. And how many companies are there which earning less than 30% of the sales are 22 plus 38 plus 46 is 106, then 141, then 161. This is the cumulative frequency. This is the cumulative frequency. So in a less than way. Now the median value is 161 plus 1 divided by 2 is 81st item. This is the 81st item. So you need to locate this 81st item is the frequency. Locate this on y-axis. Here is the 81st item. 81st is here. So draw the horizontal line parallel to x-axis. So first you need to draw the graph according to this this data series. On x-axis you need to take the data values 10, 20, 30, 40 and 50, and on y-axis you need to take the frequency values. So here is the frequency value. Then you draw the graph. For 10 it is 22, for 20 it is 60, for 30 it is 106, then for 40 it is 141, then for 50 it is 161. So this way you can draw the this graphical curve, which this is known as the less than cumulative frequency curve. Now where is the 81st item on y-axis? This is the 81st item on y-axis. Now you need to draw the horizontal line parallel to x-axis, and this line will intersect to this curve here at this point. Now from this point draw a perpendicular on x-axis, and this touch point will be the median value. So this median value will be 24.46. You can clearly see this value on the graph, actual graph. You can easily find out this value on actual graph. So this way you can locate the median value on the graph. Now calculation of mod. What is mod? Mod is the value that occurs most frequently in a set of observations. The point of maximum frequency around which other items of a set cluster densely. So most of the items are clustered at that particular point, and this is known as the mod. Utmost important to the large scale manufacture of consumption of items, such as here you see the example. In a ready-made garment shop, you will find the garment of that size which fits most persons rather than the garments of mean size. So most of the garments in a ready-made garment shop are of the garments that can fit to the most of the persons. So this way, this is the mod. This is, you can understand the value of mod. What is the importance of the mod? So this way you can understand the importance of the mod. Now how do you calculate the mod for an individual data series? This is just, you can calculate by just an inspection method. So here some data values are given, and what is the mod? Here 8 is repeated 4 times, and this is the most frequent, therefore 8 is the mod. Now for discrete series, here the frequencies are given. 1100 earned by 2 persons, 1200 earned by 4 persons, 1300 earned by 8 persons, and 1400 earned by 10 persons, and so on. So the most the frequency, the greatest frequency is for 1400, therefore the mod is 1400. This is the way you can calculate the mod for discrete data series. Now how would you calculate the mod for continuous series? The formula for calculation the mod for a continuous data series is L1 plus F2 divided by F1 plus F2 multiplied by I. So I is the class interval, L is the lower limit of the model class. First you need to locate the model class for a continuous data series. Class having highest frequency, the model class which has the highest frequency. F1 is the frequency of the preceding class interval. F1 is the preceding class interval. F2 is the frequency of the next class interval, next, that coming after the model class, and the preceding class is that coming before the model class. I is the class width. So you can better understand the calculation of mod for a continuous series by an example. So here is an example. The class intervals are given in the first column, and the frequency of the class intervals are given in the second column. So what is the model class? 72 is the highest frequency, therefore 21 to 28 is the model class. So L1, lower limit of the model class is 21. F1, the frequency of the preceding class of the model class, frequency of the class interval which is preceding, coming before the model class, and this is 36. And F2 is the frequency of the class interval which is coming after the model class. So F2 is 51. This is 51, and the preceding class, the frequency of preceding class is 36. Frequency of the class which coming after the model class is 51, and I is 7. The class width is 7. So the mod is 21 plus F2 51, then F1 is 36, then plus F2, then multiply by 7. So 21 plus 4.10 is equal to 25.10. Therefore the mod for this data value, continuous data series, is 25.10. So this way you can calculate the mod for a continuous data series. Now how would you locate the mod on the graph? First you need to present the data in a form of a histogram. So here the data, first take the class interval on x-axis, then frequencies on y-axis, and draw a histogram. Rectangles according to the corresponding to the height of the frequencies. So first you need to draw a histogram according to the frequency of the class interval. The tallest rectangle is the model class. This is the tallest rectangle. This is the model class. Now join the top corners of the model rectangle with corners of immediate adjacent rectangles. So this 14 to 21 is and 28 to 31. These two rectangles are the adjacent of the model class rectangle. Now draw the then meet these points from this corner to this corner and this corner to this corner. Now this is the intersection point. From this intersection point, draw a perpendicular on the x-axis. This touch point is the mode of the given mode for the class interval or the continuous data series for the given value. This is the model class. This is the mode of the class interval, and you can easily find this on graph. So this way you can find out the how would you can understand how would you locate the mode on a graph. Now empirical relation between mean, median and mode. In case of symmetrical distribution, mean, median and mode are same. Symmetrical or normal distribution, all three values are same. That is mean equal to median and median equal to mode. But in case of asymmetrical or skewed distribution, the difference between mean and mode is 3 times the difference between mean and median. This can be showcased by this equation. X bar minus z equal to 3 into bracket x bar minus m. X by mean minus mode equal to 3 times the mean minus median. The equation can be rewritten for mean, median and mode. If you want to calculate the mean from this equation, the mean will be 1 by 2 into 3m minus z, and median, this will equal to 1 by 3 into 2 into mean minus z. And for mode, you can calculate the mode also from this equation. Mode equal to 3 median minus 2 mean. So this is the empirical relation between mean, median and mode. So here is a quick recap of this video lecture. The median for odd number data series is size of n plus 1 by 2th item. The median of even number of data series, average of two middle numbers. Median for continuous data series given by this formula, L1 plus n by 2 minus CF divided by F multiplied by I. Mode is the value that occurs most frequently in a set of observations. Mode for continuous data series given by this formula, L1 plus F2 divided by F1 plus F2 multiplied by I. I is the class interval, F2 is the frequency of the next class, F1 is the frequency of the preceding class of the model class, and F2 is the frequency of the next class of the model class. L1 is the lower limit of the model class. In case of symmetrical distribution, mean, median and mode are same. For skewed distribution, the relation between mean, median and mode is given by this equation. X bar minus z equal to 3 into x bar minus m. I hope you have enjoyed this video lecture, and thanks for staying with me. Have a nice day. Like and share this video and write your feedback in comment box. Then subscribe, Shake Hand with Life YouTube channel and press the bell icon to get notifications for future video uploads.